Okay, so in this problem we're asked to determine whether the forces applied in each of these cars, whether these systems are statically equivalent. And so to do that, we're going to go ahead and do our sum of the forces in the x direction, so the forces in the y direction, and sum of our moments for each of our systems, and compare them and see whether or not they're equivalent. So if we start off with car A, we do the sum of our forces in our x direction, and we define x to be positive in the right direction, or towards the right, and y to be positive towards or upwards. Then our sum of forces in the x is going to be, we have a negative 30 and we have a negative 50 pound forces. So we have negative 30 minus 50. That's equal to negative 80 pounds. Sum of our forces in our y direction, we have a 1,400 pounds going down, so negative. We have a 600 going up and 800 going up. So that is 800 pounds plus 600 minus 1,400. That's equal to 0. Now for the sum of our moments, we're going to pick a point where it's somewhat strategic for us to determine our moments, and in this case we can pick the center, because in that case we get rid of that 1,400 pounds where that force is not exerting any moments. And so we're going to start off by using our writing down our positive moments. So our positive moments is this clockwise by that 800 pound force. So it's 800 pounds times the moment arm compared to that point in the middle of the car. That's 4 feet. And then our negative moments, or counterclockwise, that's going to be minus 50 pounds times, there's 2.5 feet there, then minus 600 pounds, which is this force right here, times its moment arm, which is 5 feet, and then minus 30 pounds times its lever arm, which is 2.5. And that is going to give us a moment of 0 pound-feet. Okay. Now for our car B, we're going to do again our sum of forces in the y and the x. So in the x direction, we only have our force, our 80 pound force, going in the negative direction, so negative 80 pounds. In the y direction, we have 600 pounds going up, 800 pounds going up, 1,400 going down. And that is equal to 0. For our sum of the moments, we're going to start off by using our positive moments. Again, we start off by choosing our strategic point G, because at that point we get rid of that 80 pound force and 1,400 pounds because they don't exert any moments. And so our positive moment, which is counterclockwise, is the 800 pounds times its moment arm, 4 feet. Then 600 pounds, that is a negative moment because it's exerting a negative or clockwise rotation. So 600 pounds times 5 feet. And that is going to give us 200 pounds of force, pound-feet. Okay, And so now when we compare them, the sum of our forces in the x direction, it's equal for both. It's negative 80 pounds in the x direction. It's 0 pounds in the y direction. But when it comes to our moments, they're not equivalent. So in this case, our systems are not statically equivalent because our moments are not equal.